Good morning, students. Today we are going to discuss about gas laws. As you all know that gases or gaseous state is the state of matter in which the particles are very loosely packed and the particles keep on moving with a fast speed because due to their very loose packing, particles do not experience or they experience very little intermolecular forces of attraction. So due to this property of gases, they do not have fixed volume or fixed shape. The volume is depends on the temperature and pressure conditions. Means if we place a gas in a particular container of 1 liter, then it will occupy that volume, and if we increase the pressure, then the volume is decreased obviously, and if we keep that container open, then it will occupy the entire volume which is provided to a gas. So hence these gas laws are based on these assumptions, or you can say these the characteristics of particles of gases. So let us discuss them one by one. Actually, gas laws are simple mathematical relationships between temperature, pressure, volume, and amount of a gas. And you can easily calculate one unknown variable if you know the other variables for a particular gas. First law was given by Boyle's, and it is said to be as pressure volume relationship. The Boyle's law states that volume of fixed mass of gas varies inversely with the pressure at constant temperature. Means if fixed mass of a gas is placed at a particular fixed temperature, then if we vary the pressure, if we increase the pressure, its volume will decrease. You can consider a case where you have kept a gas in a cylinder at fixed temperature and the mass of the gas is also fixed, and suppose initially the volume is maybe 1 liter and atmosphere pressure is, suppose the gas is kept at atmospheric pressure 1, and if you increase the pressure by 2 atmosphere, then you will find that volume will be decreased to 0.5 liter. So in this way we can say that directly dependence on pressure and temperature, where we increase the pressure, volume of the gas is decreased. And in 1662, Robert Boyle discovered that gas volume and pressure are related mathematically. If you double the pressure on a sample of gas at constant temperature, it reduces its volume by 1/2. So reducing the pressure on a gas by 1/2 will get the volume of the gas to double. So this mathematical representation of Boyle's law is V is inversely proportional to pressure. So V is equal to K 1 over P, where K is the proportionality constant, or we can also say PV is equal to K. So this you can see that when we increase pressure on a gas, its volume is decreased, and the curve which can be plotted between P and V is called as isotherm. Let us see the graph obtained when we plot a curve between pressure and volume for a particular gas at constant temperature. As the temperature remains constant, hence the curves or plot for pressure and volume for a gas is also called isotherm. So these are different types of isotherms obtained when pressure is plotted against V, and when pressure is plotted against 1 over V, then we obtained a straight line inclined towards x-axis. And if we plot a curve between pressure and volume, product of PV and P, then it will be a straight line in parallel to x-axis. Here, suppose if we have taken a gas initially at a pressure P1, where the pressure is higher and the volume is V1. Now if we decrease the pressure by pushing the piston upward, then you can see that in second case volume is also increased. So here you can see that product of P1 V1 is always equal to the product of P2 V2. Hence we can say product of pressure and volume for a particular gas at constant temperature is a constant value. It remains constant always. Hence we can apply this relationship for two different conditions as P1 V1 is equal to P2 V2. Next, second law is Charles' law, which is also called as volume temperature relationship. Actually, the quantitative relationship between volume and temperature was first discovered by a French scientist, Jacques Charles, in 1787, and he formulated this law in 1802, which is known as Charles' law, and it states that volume of a fixed mass of gas at constant pressure varies directly with the temperature in Kelvin. Otherwise, if we consider temperature in degrees Celsius, then the law defines as the volume of a fixed mass of a gas at constant pressure increases or decreases by 1 over 273 of the original volume at 0 degrees Celsius. The mathematical formulation for this law can be written as V is directly proportional to T in Kelvin, or V is equal to KT, or V over T is equal to K. That means the ratio of volume and temperature, Kelvin temperature, for a particular gas at constant pressure is always a constant term. Here you can see that if we heat a particular fixed amount of gas at a fixed pressure, then the volume of the gas is increased, because at high temperature particles start moving faster, and when they will move faster they will occupy a large volume. And the curves which are obtained for volume and temperature for Charles' law are said to be isobars, as pressure remains constant in these curves. That is why they are called isobars. The volume and temperature, when temperature is taken in degrees Celsius, then the curve is obtained like the first curve, where you can say that the volume becomes 0 at minus 273.16 degrees Celsius, and this temperature is called as the lowest possible temperature, or you can say at this temperature the volume becomes 0, means gases cease to exist at 0 Kelvin temperature. Later on, this scale of Kelvin temperature was used, and the graph, if we obtain a curve between volume and temperature in Kelvin, then second type of isobar is obtained. And for different values at different pressures, the curve is obtained like the third one. Now if we consider a fixed amount of gas at a fixed pressure, if it is placed at a temperature T1, then its volume is V1, and when we increase temperature at T2, the volume also increases up to V2, as you can see here in these two balloons. So this ratio of V and T will always be a constant value. That means V1 over T1 will always be equal to V2 over T2. And this Charles' law can be easily applied on hot air balloons, which actually rise up due to when the air is heated up in that balloon. Then on heating, the volume of the air increases, and thereby decreasing its density, and it rises above. That is the basic principle behind hot air balloon phenomena. So Charles' law can be related to two different states at temperature V1 T1 is equal to V2 over T2. That will be always a constant, and we can find the value of one unknown variable if other three variables are known. Third law is called as Gay-Lussac's law, and it is actually a pressure temperature relationship for a gas at a fixed volume. Now Gay-Lussac stated that pressure of a fixed mass of a gas at constant volume varies directly with the Kelvin temperature. Means if we increase the temperature of a gas, the pressure of gas also increases. If we consider temperature in degrees Celsius, then also this law can be defined as the pressure of a gas changes by 1 over 273 of the pressure at 0 degrees Celsius. But in Kelvin, it can be written as directly proportional to temperature. Here we can see two different cases. In first case, a gas is placed in ice bath, the same volume, the same amount of gas, and the volume is also fixed, and you can see that pressure in the manometer comes out to be 1 atm. But in second case, when the same volume and same amount of gas is placed in boiling water, then the pressure increases 1.37 atmosphere. That means when we increase the temperature, what happens? On heating, the volume, the kinetic energy of the gaseous particles increase, and with increase in kinetic energy, the particles start moving faster, and when this move faster, obviously they will collide at fast speed, and they will also collide with the walls of container with very fast speed. And when collisions will be faster, obviously a higher force will be exerted on the walls of the container. That increases the pressure of the gases. So mathematically, we can represent pressure of a gas is directly proportional to temperature at constant volume, and it can be written as P is equal to KT or P over T is equal to K. That means the ratio of pressure and temperature for a fixed amount of gas is always a constant for a fixed volume. So the curves which are obtained for pressure and temperature at fixed volume are said to be ISOCHORE, and they will also be a straight line inclined towards x-axis. And if we plot a curve between P over T and P or T, then it will be a straight line parallel to x-axis. And for two different conditions for a particular gas, we can also write the equation as P1 over T1 is equal to P2 over T2. And we can find any one variable out of these four if other three are known. And the fourth gas law is given by Amedeo Avogadro in 1811, which states that volume of a gas is directly related to the number of moles of a gas, provided that temperature and pressures remain constant. That means, and this law can also be defined as volume of each and every gas is directly proportional, or you can say equal volume of all gases contain equal number of moles if they are placed at same temperature and pressure. Mathematically, this law can be written as V is directly proportional to N, V is equal to Kn, or V over N is equal to K. That means the ratio of volume and number of moles for a particular gas is always a constant at constant temperature and pressure. Now suppose 1 mole of a gas is occupying 1 liter volume at a particular temperature and pressure, and the same for the same gas at same temperature and pressure, if we are taking 2 moles of that gas, then volume occupied by those particles will be 2 liter. That means we can say V1 over N1 is always equal to V2 over N2. Ratio of volume and number of moles will remain constant for a particular gas, if for any gas you can say at fixed temperature and pressure. Now by combining all these laws, we can express the relationship between pressure, volume and temperature for a fixed amount of gas, and this law can be used when 2 or 3 variables are being changed for a fixed amount of gas. For example, if we change both the pressure and the temperature, what will happen to the volume? Because of the complication of two or more changes, we have no way to visually predict what will happen to the gas. So we must go straight to the mathematical expression as P1 V1 over T1 is equal to P2 V2 over T2. Any one variable can be calculated by knowing the other variables by combining all these laws. Next is ideal gas equation. So very important formulation for gases, that when we combine these laws, from Boyle's law we get V is directly proportional to 1 over P. From Charles' law, V is directly proportional to T. From Avogadro's law, V is directly proportional to N. And ideal gas equation can be derived by combining these three laws as V is directly proportional to N T over P. And when we remove proportionality sign, we get a constant R, which is known as universal gas constant. And this equation PV is equal to nRT is called ideal gas equation, and this is also called as ideal gas law. Means the gases that satisfy this equation for entire range of pressure and temperature is said to be an ideal gas. So again, ideal gas equation or equation of state for an ideal gas is equal to or is represented as PV is equal to nRT, and for 1 mole of a gas you can write it as PV is equal to RT. That is, product of pressure and volume is always equal to the product of universal gas constant and the temperature for 1 mole of a gas. R is known as universal gas constant, and value of R varies with the values of pressure, volume at various in various units accordingly. So if we put values of these variables like pressure in 1 atm at using STP conditions, standard temperature and pressure, where pressure is 1 atm and volume is 22.4 liters and number of moles we are taking for 1 mole, and temperature under STP is 273 Kelvin, that is 0 degrees Celsius. So by putting these values, we will get the value of R 0.0821 liter atmosphere per Kelvin per mole. Now if we are using pressure in bar and volume we are taking in liters or decimeter cube, then the value of R which is used is 0.0831, because at by taking pressure at 1 bar, the volume of 1 mole of a gas is 22.7 liter. So on putting those values, R is calculated as 0.0831. Now if we use units in SI measurements, that is, if pressure is taken in Pascal, that is 101.325 Newton per meter square, and volume is considered in meter cube and SI unit, that is 22.4 multiplied by 10 raised to the power minus 3 meter cube. Then putting these values in equation of R, we have this value of R as 8.314 joule per Kelvin per mole. So these three different units of R, universal gas constants, are to be used while solving mathematical calculations. So always remember these formulas. For Boyle's law, P1 V1 is equal to P2 V2. Charles' law, V1 over T1 is equal to V2 over T2. Gay-Lussac's law, P1 over T1 is equal to P2 over T2. Combined law, P1 V1 over T1 is equal to P2 V2 over T2. And ideal gas law is PV is equal to nRT. In place of volume, if we are to be used density, then the law term comes out to be as volume is inversely related with the density. So in terms of density, we can also use P1 over T1 D1 is equal to P2 over T2 D2. Hope the things are clear to you all. Thank you and have a nice day.